Phase 1 of Jisc's Virtual Research Environments programme funded 15 projects across the UK. The projects, located in departments across the research spectrum, all sought to investigate the technological challenges surrounding virtual research environments, or VREs, each developing a VRE suitable for use in its own academic domain. VREs can help researchers of all disciplines to manage their increasingly complex workloads by providing a framework of resources to support the underlying processes of research on both small and large scales. VREs have their roots in virtual learning environments, or VLEs, which have become increasingly common across further and higher education institutions. Most universities and colleges use either commercial VLEs such as Blackboard or open source frameworks such as Sakai to coordinate and assist with administration and teaching and learning. VREs, however, offer an extra dimension of functionality and tools and allow users to really begin to engage with and collaborate in the collection and exchange of their data by giving the end user the capacity for analysis and cross-communication, all within one application. In Oxford, IBVRE, the Integrative Biology VRE project team, sought to build a VRE demonstrator to support the Integrative Biology Research Consortium with work that was being carried out in the field of heart modelling.
The project was open-ended, so the end user was essentially the whole of the computational biology research community. But what we did when the project started is we went around the consortium and we interviewed people, sort of a representative sample of the community, and we also ran a focus group at their annual workshop, and we tried to understand what their high-level requirements were and put those requirements in some sort of order in terms of priority. And what came out of that is we identified a couple of groups that we wanted to work with, and we decided that the biggest thing that we needed was to develop essentially a repository of experiments for those two research groups. The design methodology we used involved the end users very much in the process. So we actually went over to the States twice, where we had 2 week-long workshops where we got people in a room together to sort of understand how their research process works at a very detailed level. In the case of the first people we visited, that was James Eason's lab at Washington Lee University in Virginia. He mainly works with undergraduates. These people, they're very good on biology, they're biology majors, but they don't necessarily know the technical intricacies of how to run simulation experiments. And they wanted a point-and-click interface that would allow them to very simply run these experiments without needing to know how to set up compute resources and all the rest of it. Whereas that the other lab we visited, which was in New Orleans, which was Natalia Trianova's lab, they were a much more technical group, made up of graduate students and postdocs. And they wanted a much more general VRE that would allow them to do many different types of experiments.
At the University of Hull, the Political Discourse project team wanted to explore the potential of working within an existing open-source virtual learning environment framework, Sakai, and tailor it to suit their own needs. Along with investigating use of the access grid, they wanted to see how the humanities, and specifically the history of political discourse, could benefit from working within a VRE.
We think it's perhaps a distinctive feature, and maybe even a unique feature of this particular VRE project, is that 5 professional historians who were instrumental at all stages in designing, or at least in saying what our requirements were and what we wanted out of the VRE. So the project has been directed on a day-to-day basis by historians to meet their own perceived needs. Our first major sort of user requirements exercise was conducted in the first spring. Using Sakai as a basis, it was effectively a gaps analysis. What does Sakai currently do? What do we need it to do to support the sort of research that we want to achieve? Essentially, we had a day's event where we brainstormed what we would need. We looked at what Sakai already did, and then we sort of tried to find ways in which we might, either ourselves or knowledge of what was going on within the Sakai community, those gaps would be bridged. Essentially, our needs were very straightforward: communication tools of various sorts and a collaborative authoring tool. The collaborative authoring tool, the wiki, didn't at that time exist within Sakai, but I believe it wasn't very long into the life of the project that we knew one was being produced, and so I think that definitely tipped the balance in favour of staying with Sakai. We took technologies which were available, we tweaked them to some extent according to our needs, but we didn't really create technologies de novo ourselves. We took what was available, we put them in the hands of practicing historians, and we said, go play.
At the University of Manchester, ISME, the integration and steering of multi-site experiments to assemble engineering body scans project, looked at a lightweight collaboration solution for multi-site engineering experiments and how they could be facilitated through the implementation of a VRE.
I've been working at large facilities with a large group of students and postdocs and also industrialists and instrument scientists, all working together to undertake experiments. Those experiments might last for 72 hours non-stop, and so they're very pressurized and you have to make decisions very quickly. And what I was aiming to do was to try and make sure that we could all work together, even if we weren't all in one place. We were very keen to try and make sure that this could be used in situ. And that would include the scientist at the beam station, it would include the scientist at the university, but also it could include the professor or the industrialist at home. And so we had to target on 1 or 2 megabit bandwidth, and that really was a very educating experience because we had to then cut down and refine what we were going to provide to make sure that we could get that through that kind of portal. And that worked very well because it's no good saying to someone who's working late at night, well, ring up your supervisor, get them into Manchester, get them into a conference suite and we can sort the problem out. You really want to be able to say, right, we can ring up our supervisor, let's get them down to their office in their house and use a simple broadband line. And that was something we achieved, but it did require quite a discipline in our approach.
Also in Manchester, the Collaborative Stereoscopic Access Grid Environment Project, CSAGE, wanted to incorporate portable stereoscopic equipment for 3D visualization into the access grid environment to enable collaborative research across a diverse range of disciplines.
We at Manchester Visualisation Centre within the university have been working with a large range of different faculty users, and the opportunity came to actually integrate it with a virtual research environment for presenting data to all kinds of users. So this involved not just the sciences and the medical teams which we've been working with actively, but also the arts, humanities, earth scientists, geologists, social scientists. And we wanted to bring our system which was then usable. So it was cheap, convenient, easy access, but also to bring it into the philosophy Jisc had for this virtual research environment, which was almost a cradle-to-grave electronification of the research admin, research technology, research terms and research presentation. We worked on a two-phase structure where we built a big prototype system first time round and then asked them for evaluation. So the process was in practice. This actually meant that we gave them a set of tools, but we made sure they were all very modular. If they didn't want a text chat system working at the same time, they could switch it off. If they didn't want a time-lined PowerPoint presentation, which the arts didn't want, they could turn it off and they could just work on a mind mapping tool annotation system. If they just wanted a presentation of 3D art forms for stereo presentation, they could just switch over to that mode. So everything was a modular area and they could just learn and understand the bits they needed. Then when a second round of development occurred, we could say, well, okay, these were useful and these weren't, and try and improve upon them. And what we're planning on the third round is, because most of these are open source modules developed by third parties as well, is able to feed back information which says how they can improve it.
By really focusing on what the real needs and concerns of their researchers were in their specific institution and domain, each project was able to create a VRE tailored to their own end users. In their heart modelling experiment, the IB VRE's environment aided their two different project teams in different ways. Where the one team wanted an easy-to-use interface for students, the other used a personally customisable system for the more technically aware researchers. The University of Hull used their VRE not only for already published research purposes, but also as an environment in which to aid and assist the teaching of an MA course, and they plan to continue working with Sakai into the future. ISME developed tools that have proved useful to aid in the visualisation and communication of multi-site experiments, with the potential to allow scientists and both students and researchers to maximise their experimentation time in a pressurised environment. CSAGE has been used for, amongst other things, research in the field of dance and for 3D visualisation of mummies, so that they can be studied in far greater detail. Although all of the projects funded by Jisc on the surface appeared to be dealing with separate issues, they all concluded that it was the research that was key, and any environment developed cannot afford to be perceived as an interference with or an extra layer on top of that research.
I think VREs will cease to be something special. We have a special term to describe this kind of communication. I think in the future people will just communicate, and we won't have a special subject. It will become just a way of passing information one to another, just as we're talking now.
VREs essentially should be a way of matching tools and technologies to end users, and understanding the needs of researchers and finding the appropriate technologies for those users. I don't believe that VRE is a specific flavour of technology. I don't believe VREs are necessarily portals or any other type of technology. I think VREs, if they're going to be a success, should be very much about understanding the needs of researchers and giving them appropriate technology, and where necessary, doing bespoke development to bridge the needs that those research groups don't have the resources to meet those needs.
People are just going to do research, and people are just going to say, we'll do research. You don't say you're going to surf the internet, you say you're going to search for something. So people are just going to use the tools without actually calling them VREs. And a VRE in the long-term future should be a whole set of tools already built up which are interoperable and transfer. Then people will choose their own tools for their own research, but it will still obey a few of the guiding rules. One is to record everything and archive it, and then one is to annotate everything and be able to post-annotate and post-archive, so that researchers in 3, 5, 100 years will be able to look back on the data and then extract more information. So that's the future. The future is the VRE won't exist. It will just be used.